And I'll send some reminders to the people who are still asleep, and that's going to do it. All right. Well, who read the essays on the website? Do you even know what I'm talking about? These two right here in the resources. All right, so remember that one of your assignments for last week was to read, watch all of the resources below, including those two. So if you didn't, you're a bad person and you need to seek forgiveness. I'll forgive you as long as you get it done. All right. I was hoping to actually start out talking about these two essays, but I'm guessing that that'd be none of you read them. Is that accurate?
Seems like that.
All right. Well, I hope you feel deep shame right now. Use the website, do the assignments on there. This is how you start to understand what we're actually doing, get some practice. Okay. Well, I'll just briefly talk about these. It's about command line bullshittery, and it's what you're doing right now. So these are going to be interesting essays for you. As we start assignment 4, one of the first things that we're going to do is download somebody else's bioinformatics software and figure out how to get it working on our computer. Okay. This is not intellectually stimulating work. It's not solving the mysteries of biology. It's just necessary prerequisite to get stuff done in here, and it can sometimes come across as bullshittery, as these essays we'll talk about. And so read through those. I want to chat about them on Wednesday in that case. Wait, what is today? Tuesday. So Thursday. We'll chat about them. All right. Well, today we're going to cover the two most basic types of DNA sequence data, FASTA and FASTQ. And we're going to get some practice working with a couple new programs. You remember grep, right? Where you look for some pattern in some stream. All right. Today's new program is SED, S-E-D. This stands for Streaming Editor. Okay, what's a stream?
It's something that processes things one line at a time.
Yeah. So it takes standard input and it edits it as it sees it, one line at a time. Okay, so if I echo ACCTGC, that's my program, that's my standard input, this is my standard output. I could pipe that to SED. Okay, so I could edit that one line as it comes through. Now don't get too hung up on this syntax. It's weird, but you'll learn it in just a second. All right, what did SED do there? Yeah, can you see my screen?
Change the C's to a Y.
It did. So this is basically like a find and replace, okay? But if you were to open up a FASTQ file in Microsoft Word and try Control H for find and replace, it would crash your computer. All right, in this case, we're doing it one line at a time. It's reading the stream in, editing one line, and then streaming that out. All right, so the syntax here is sed, so the command is streaming editor, and then in quotes, we're saying, all right, what we're doing is searching. We're going to search for the pattern C. We're going to replace it with Y, and we're going to do that globally. There's a lot we can do with sed. We could spend 2 or 3 weeks learning about sed, but I'm going to show you how to learn about it and the most basic syntax, which is search for something, replace it with something, do it globally. All right, how would I replace Y's in this example back with C's? Either tell it to me or throw it in the chat. Echo ACCCC to YC.
Reverse.
Okay, so Ernie, let's try yours out. It didn't really do anything. All right, so Reagan has said we can just start out with the Y's. So now that there's something to change. Here, sed didn't find any Y's, so it didn't actually make any changes because that was our standard in. Here we're giving it the AYYY, so that works. I could also just pipe this right back in. Search for Y, replace with, I'll do a lowercase c so we can see the change, do it globally. All right. So I know it may seem kind of hobbled together, but that's what bioinformatics is a pipeline held together with duct tape and speaker wire, right? But we can chain together a bunch of seds to accomplish a lot of stuff. Okay. Your assignment 4 has you downloading a couple files. I'm going to paste these in to our chat. So let's go ahead and get into your directory in your terminal. We'll look around. Okay, assignment 3 is in there. I'm gonna make assignment 4. Oops, make assignment 4 and then go into it. I'm gonna make some directories, data, output, scripts, just my standard 3. CD data, and then I'm gonna get file 1 with wget. I'm gonna get file 2. All right, so there they are. Let me know when you have those in a reasonable spot in your assignment 4 directory. Does anyone need me to refresh you on what I just did? Did I type too fast? Is anyone there?
Yeah.
Okay.
Still working on it though.
Okay. So you Windows folks, looks like most of you managed to get wget working. Right? Are you all asleep today? I'm not getting like any feedback from
Yeah.
you.
We got it working.
Okay.
Did you save the FASTKey file in data?
Did I save it in what?
It's
In
a-
data, yeah.
Okay.
So I just stuck mine in data. You can stick it wherever you think is a good spot.
Hey, I had something weird happen.
Okay.
My desktop is no longer listed in my
In your
like
home.
yeah.
Okay. So if you do ls tilde / that's shortcut for home, and you don't see desktop there,
No.
Windows?
Yeah.
Okay. The new Windows does the virtual desktop thing. It's actually stored on the cloud.
Okay.
The Microsoft Cloud, I forget what it's called. And so it can come and go. And so maybe it's best if you give yourself a new directory somewhere in home.
Okay.
So you could do make dear home BINF assignments, and that's not going to go anywhere.
Gotcha.
And that'll always be
Yeah,
in the same spot.
I'll do
Yeah.
that real quick.
Okay. Yeah, the weird like cloud storage stuff is kind of puzzling to me. I mean, it's not like it's magic. It's just somebody else's computer that your desktop is living on. That's what the cloud is. And so probably best not to put stuff on there if it's disappearing like that. That's all part of the command line bullshittery.
Was it 2 files that we needed to download?
Yeah. So we've got assignment 4 file 1, assignment 4 file 1, .fastq.1. Okay. All right. So let's take a look at the first few lines of that first file. All right. Nice and confused? Make this a bit bigger so we can see it. All right, so this is the format that DNA sequence data comes to you from a sequencing machine in. Unless you're using an old school Sanger sequencer where it comes in this .av1, because that's actually just like a color chart. But for the most part, that's kind of going the way of the dodo. So this is our first 2 lines of the file. If you double click in the terminal, it should, or triple click, it should just highlight 1 line. So I double click on this, you'll see that it's actually just wrapped around. So that's the second line. All right. So this is FASTQ. The first line of a sequence starts with an @ symbol. And then there's the name of the sequence. The second line is the sequence itself. All right, then we get a plus sign. And then we get the sequence quality. What do I mean by sequence quality?
What about complete the sequences? Like how many unknowns, that kind of thing.
It's each one of these little characters here corresponds with the same position. And so the sequencing machine said that the first nucleotide of this sequence is C, and then it assigned that C essentially a probability, how sure it is that it's right. Okay. And then it said the second nucleotide is T, and assigned it that probability. T, there. All right, so this is really confusing looking, but each one of these characters refers to what's known as a Phred score. Chapter 10, which you should have looked over by now, but definitely will have read by Wednesday, talks about what these actually are. Okay, if I want to look at them, I'll paste these up as well so you can just kind of see. These are the quality scores of the different bases. Post this link in for you. All right, so what we're looking at here is even more confusing than you thought at first, because there's two different ways, technically three, of describing quality. Okay, so this is the probability of an error. This is the Phred score, and then this is the character that denotes that. Okay. So let's take a look at our little file here. So we've got our sequence identifier, and then this nucleotide C, and then we get an @ symbol associated with that C. So what's the quality of that C if it's an @? Terrible, yeah. Pretty bad. All right, what about the T here? So our first one was an @, and we said that's terrible. Then the second one that we're looking at is a C. Oh, wait, so Heath, you say this quality score is 31, not 64. Aha. All right, so we've already found our first problem with the FASTQ file format. @ can mean we're really uncertain about this score, or it can mean pretty good. Because there's this version of the quality scores, and there's this one. Isn't that exciting? All right, what about the letter C? That could mean 50% error rate, or it could mean 0.04% error rate. All right, so how do you know which version to use?
Would it be in the name of the file anywhere?
Nope.
Hmm.
You just hope they tell you the right one.
You hope they tell you the right one. Yeah. Okay, so you may notice that there's no lowercase characters up here. That's usually a nice giveaway. If you see lowercase, you're using this base 64 old Illumina. Nowadays, it's gonna be here, this base 33, this new Illumina Ion Torrent. Okay, so this is what you're gonna see typically, but if you're working with older sequence data, you may have to take that into account. Right. So this file format already has some trouble. It's got some more trouble. How would I count the number of sequences in this file? How did we do it for our FASTA files? I go.
Yeah, in the ads wouldn't quite work here, huh? That's it. Yeah, no.
Yeah, we said grep count things that start with greater than, and that gave us the number of sequences. Okay. Trevor says grep at. Well, I don't know about that. Because at is also representative of a quality score. Where'd you go? Fred score of 64. And so it would count this line and that line. No, it wouldn't count that line, just this one. Can you be guaranteed that every single one of your reads is going to have one and only one at next to it? Maybe you could get away with counting lines that start and then end with plus. Could maybe do that. That could break on you. If you had a sequence of length 1, it's not likely, but it's possible. So what could we do?
You could find lines that are the same length. Kind of.
Sequence reads aren't always going to be the same length. And
the line would be right.
well, I mean, consider
Yeah,
our
like something.
seq name, and then AATC, and then a plus, and then FFGD. All right, so that represents one sequence. So yeah, Heath says you could count plus and then line returns. So we could count lines that start and end with plus. So it's lines that just have a plus on them. Trevor says word count lines, then divide by the number of lines per sequence. As long as everything works perfectly. it's 4 lines per sequence, so we could just count up the lines and divide by 4. If you're very certain that there's no mistakes in your file, it didn't get cut off prematurely, the sequencing machine sent back everything nicely, then you could do that. I would say that dividing by 4 is probably better as an estimate of the number of sequences you have. So let's try this. Let's try to find a way to count things that start with plus and then end. All right, so I've got my Sun4 file 1.fastq. I'm going to say cat that. I'm going to pipe that to grep c, things that start with plus and then end. So I know it's been a long weekend and everything, but this little character means starts with, $ means ends. And so this should count the number of lines that start with a plus and then end. I've got 32. Okay. What if I wanted to turn this into a FASTA file so we could then just count the greater than symbols? We'll put this in our chat. Now, looking at that, I don't want you to bother trying to read it right now because it's written in another language called Perl, which SED is capable of using. But that little command there will actually convert from FASTQ to FASTA. So it's looking for things on 1 through 4 lines. So it's looking 4 lines at a time, finding the first thing that starts with an at, changing that to a greater than. It's doing that just for that line, and then it's printing lines 2 through 4 afterwards. Okay, so let's try this. I'm going to cat Sun4 file 1 and then send it to SED. Why didn't that work? Oops. I stuck an extra quote at the end there. That's not good. Okay, so take off that little quote. The one right at the end there, it shouldn't have the 2. No, it should. Now I've screwed everything up. Let's see here. SED and that quote, that quote. Now I've gone and totally screwed this up. Okay. Where were you? Sun4. So I also put this here for you. Yeah. I think I did mess it up. Yep, that got thrown in. All right, I'm gonna paste the real version for you. Okay, isn't this exciting? This is command line bullshittery in action. All right. So this right here will convert a FASTQ to a FASTA. All right. You don't need to memorize this. You can save it as an alias if you want. I can help you walk through that if you need help with that. So for me, I made an alias called FQ to FA, and that's it. All right. Okay, so let's regroup. If we've got this sed command, this big ugly thing, and we're doing it to assignment 4 file 1.fastq, how do we then count the number of sequences? Using a pipe. Grep. Yep. Trevor is spot on. Okay, so we've got that. We pipe it to, we could do grep, things that start with that, and then word count L, or we could do grep -C also as a little shortcut, and that gives us 32 also. Okay, please let me know if you don't understand what just happened here. I'm not worried about you understanding the bizarro language inside the sed command. All right, Reagan, what's up?
I have an error that says invalid command code, and it's like the little tilde thing.
And let's see here.
Copy and paste it.
And you had the N, the -N on sed?
Mm-hmm.
All right, let me see your screen. Did anyone else get that error?
No.
I'll stop sharing mine so you can share your screen. All right, same for Heath. Let's check this out. Sed N. All right, I want you to try something here. After the -N in sed, so go ahead and hit up, put a -E also.
Looks like so.
Yeah. It's not gonna work. Okay, of course. Okay. So is this just people on Macs it's not working for? Is that the pattern?
Yes.
Huh. Man, bioinformatics is really fun, isn't it? Oh yeah, he's on a Mac too. Okay. Works for Cody. How about the Windows people? Is it working for you?
Yeah, it works for me.
Okay.
Mine is like working, but I think it's listing everything and not actually changing the file from a Q to an A.
No, yeah, it won't change the file. It's just that's just the standard output. You'd have to redirect it to a new file. All right, well, let's try something else. Because here in the world of command line bullshit, this is how it works all the time. Things just don't happen. Wait, you need to install sed? You don't have sed installed? Oh, wow. This is the wget thing all over again. Okay, Mac people.
Wait for Mac.
Ernie's got some code there for you in the chat. Brew install new-sed. GNU new. I'm always blown away by like what is or isn't incorporated on different people's computers. Sorry about that. I've never encountered that before. Had taught a workshop in this last year. Mac people they had sed installed. I guess they've changed that in the new OS release.
Oops, never mind. Still doesn't work.
Oh, it still doesn't work. Oh wait. Okay,
Yep.
So sed has been installed as gsed. So just add a G in front of sed if you're on a Mac.
Huh. It worked.
Okay,
Yay.
great.
Okay.
Well, that's exciting. And it says if you need to use it as sed, you can add a new bin directory and stick it in there. So you could do that. You don't need to. It's all right. All right. So if you're on a Mac, it's gsed. Everyone else, it's sed, but the pattern is still the same. And what we've done is we've taken this file, we've read it in, this time 4 lines at a time, and we've acted on those 4-line chunks, changing it into FASTA form. And yeah, it doesn't change the file. So Noah pointed this out. It just spits it to your standard output because that's what a good bash program does. And so if we want a new file, we have to.
Sure, gone.
Yeah, I need to send it. Share my screen. Okay. All right. So this is the output. You can see that it is in FASTA format. So if you want to then save this as a FASTA version of the file, you just redirect that standard out into a new file, which I'll call FASTA. Excuse me. All right, so there's my assignment for file1.fasta. So that's one way to switch between FASTQ and FASTA. You'll find yourself having to do that fairly often. The reason being that a lot of programs are written to handle that nice, tidy FASTA format, but the sequence data you have is in FASTQ. And so in order to use some bioinformatics software, you first need to convert it to FASTA. So you'll find that fairly often, less and less, thankfully, as people's computers get more powerful. One reason that they did this is because if you look at the file sizes, It's about half as big, stored as FASTA compared to FASTQ. These are really tiny files, but they can become gigabytes.
One question, don't you lose a lot of information going from FASTQ to FASTA?
Yep.
As far as quality? Okay.
You lose a ton of information. You lose all of those quality scores.
Sounds good, just making sure.
Yeah. And unless you save that FASTQ file somewhere, you can't get back that quality score information. It's gone, right? We sent it into the ether, said deleted it. All right, so this is why you don't want to overwrite your original data ever, because you're probably going to need access to those. Okay. So assignment 4 kind of gets into what we just did, downloading some new software and trying to get it to run. All right. So we've got this program called SeekTK. Since not all of you probably have multiple computer screens, I'll paste this in the chat for you. So there's your link. So somebody wrote this. That somebody was Heng Li in Boston, and is probably working with a nice team to come up with this SeekTK program. It's specifically written for working with and manipulating FASTA and FASTQ files. Okay. To install it, you basically need to run these 2 lines, and that should work. Okay. What you may run into is this library dependency. Okay. So let's talk about installing software here. There's a bunch of different ways to house your software. This one's stored on GitHub, and they haven't really made a nice installer or anything. They've just left it here on GitHub so it's easy to update, to fix bugs and all that. And they've written something called a make file. Has anyone heard of that before?
No, no.
No? Okay. A make file is something that you run to compile the software. So they've gotten like all the lines of code. Your computer still doesn't know what those means exactly, and so by running this make, it kind of compiles everything so your computer can understand it into ones and zeros. So that's really nice of them. Where is this program going to live on your computer?
Wouldn't it be wherever you clone it?
Wherever you clone it. Is that necessarily where you want it to live?
Probably not.
Probably not. Okay, so they're assuming that you're just going to stick this where you need it for now, and then every time you need to use it, you're going to have to send instructions to your computer as to where to find SeekTK. That can get old really fast. All right, so keep that in mind when you're installing stuff. Not always. In fact, most of the time when you install bioinformatics software that was written by other scientists, it's not going to be nicely incorporated into your computer's file path. They're kind of assuming that you've got some command line bullshit skills and can stick it there if you want it there. Right? And then it's nice of them to say this, because they don't always, that there's a library dependency zlib. All right, so these are instructions for your computer to make this work. So that might be something that you run into if you try to get this installed and try to run it. It may say missing library, and so then you would have to install zlib. So let's try this. Let's walk through it, and I'm certain that it's going to be different for everybody's computers. We're going to spend the rest of the class period getting installed, but maybe not. All right. So let's try it. Git clone that, and then we're going to move into it and do make. Now, I'm going to copy this first command here. Actually, I'll just copy the whole shebang. Oh, which CTK. All right, so I just asked my computer, where is my seektk installed with the which command, and it said you stuck it in user bin seektk. All right, so that might be a place where you'd want to stick it. How about this? Echo the value of path. You're probably going to want to stick it in one of these directories. All right, so echo your path. Think about where you might want to put this. If you want to give it its own directory, that's fine. We can add that later to your path. For instance, you notice that most of my path stuff starts at like user local bin. These are the binaries, that's my actual programs. But I've got some weird ones in here. I've got home gzon edirect. That's the NCBI's downloading program. I wanted it to live in my home directory. That wasn't part of my path, and so I just added this to my path. And so we can walk you through that as well. Here's another one, home gzon itsx, blah, blah, blah. Home metabat bin. So these are some bioinformatics tools that I didn't necessarily want living deep in the bowels of my root of my computer. I wanted them somewhere a bit easier to work with, and so I stuck them there. So for you, you might want to do cd tilde, that takes you home, and then do the git clone and paste all that in. And then we could add it to your path afterwards. It's up to you. You can download it into your desktop and then move it into somewhere where it exists already in your path, or you can stick it in your home directory and add the home directory to your path. You can go both ways. I want you to be aware of both and to kind of see what this path is actually doing. All right, who wants to share their screen during the download?
I just tried it and I got an error, but I don't know.
Perfect.
Error. So, let's see, Fatal cannot create a work tree direct. I went to one of the path locations.
Okay.
Anyway, says that the permission is denied.
Ah. Is that the only error you're getting so far?
Yes, yeah.
Okay. Well, you're on a Linux machine, and so you can do super user do. It's going to ask for your password. This is just your computer trying to protect from some unknown user installing stuff into your path.
Okay.
So the sudo command right in front of that
There we go.
will ask for your password.
All right, cool.
All right, and Trevor, how about you share your screen? I'm interested in this error you've got.
Can you see it?
Yes, I can see it.
So I stuck it in my bin.
Okay, so you're in your bin,
Well, yeah, it's in there somewhere.
and where is it? Let me S I guess it's scroll up a bit. Okay. Now look around in there in the seqtk. All right, so we've got makefile, got readme. All right, so that's what was on the GitHub page. Okay. And when you type in make, that's when
That's right.
things went south.
What's the error?
All right.
I didn't find any search results on it.
And is this a Linux setup?
Yeah, this is Linux.
Okay. All right. Type in GCC space dash dash version. All right, run that line. Yes. Okay, so for everyone watching this, that may have seemed like bizarre wizardry, but what happened here, when you type in make, it's actually looking for a compiler. Okay, and GCC was the compiler for Linux. It probably is for Mac as well. Okay, and so he had to download the compiler first, and then it could work, but it said zlib.h.
So we need to install that dependency, right?
Yeah, so try sudo apt space get. Sorry.
Git as in GitHub or Git
Let me
as
type
in
it for you.
Yeah.
Sudo apt get install zlib. Don't forget the hyphen between apt and get.
Yeah,
For you Mac people, apt get is basically the same as homebrew and like brew install.
Cool.
Unable. Okay, perfect. So now he's trying to get zlib because remember, the website said this is a dependency, this zlib thing, and so we tried to install it and couldn't be found. So it's going to just be named something different. It's not going to be called zlib. Oh, you're going to love this. So I googled zlib and found that it's actually called zlib1g. Perfect. Okay. So you already have zlib1g. It's set to manually installed. You know, all of you thought you were going to be learning about sequence data, but here we are. This is what happens. All right, so try this. Okay. Okay. Now it's saying, hey, you don't have permission. So try sudo make. I think it
this is
works.
saying that there's something wrong with the C code, isn't it? Variable LC set but not used.
Yeah, we're not going to worry about that yet. Warnings are not errors. All right, so now give me an ls. Okay, so it worked.
Cool, thank you.
Yep. All right, who else is having trouble getting this installed and made?
Mine had an error too, but I was trying to see if I could find it and download it and just put it straight into my user bin. Would that work?
How about you share your screen? I want to take a look. See what's going on with your error.
Shit. How do...
So, I mean, as sad as it is, this really is the process of bioinformatics. This is the limiting step. This is why not everybody is a bioinformatician. It's because of all this command line bullshit stuff. The problem being that the people who write these really awesome, very powerful programs tend to not be software developers working at a for-profit company. They tend to be scientists and people at the cutting edge of bioinformatic research, and so they need to solve a problem. They've got some coding skills, and they make a really cool program for us, like seqtk, but a lot of times it's kind of assumed that you're going to have the requisite skills to get it figured out and installed, and it kind of feels like duct tape, and it is. And it's all dependent on this weird zlib thing that you got to get installed and all that kind of stuff. And so this is the prereqs of doing bioinformatics, is being able to actually glue together all these bits of software. Once you get them all installed, it works like a charm. We'll see that. We'll be able to pipe things in, right? Standard in and standard out will still apply, but here we are. All right, so you've got it cloned. I want you to do an ls. Okay, do cd seqtk. And another ls. All right, you've accidentally cloned it twice. So you cloned it, moved into that directory, and then you cloned it again.
Okay.
So give me a cd ... to back out one. Okay, and then I want you to remove, so remove recursively seq tk slash, I'll put that in the chat. We're going to get rid of that second version you've got resting inside there, because that'll get confusing. Okay. Yeah, just give it a Y for yes. Again, you may have to just hit Y enter a few times. Okay. And now try make. Yeah, just like that. Nope, just type in make and hit enter. Okay, make command not found. Let me Google real quick. All right, so on Windows, apparently the make command isn't built in. And so I'm putting a link in the chat for you. And it's broken. No. So don't bother with that. Here's the real link. All right, so Windows has their own version of making stuff. So there's an installer. If you click that link, it's the MSys2 x86 64 2021 EXE. So run that installer. Install it in the same location that they put it in, which is MSys32. Go ahead and run it.
Mine is downloading still.
Okay. All right, were there any other Windows users that Make didn't work for?
Yeah, it's not working for me.
Okay, so yeah, try that msys2.org link. Follow the instructions on there, and that should work. So that'll be your version of the Make compiler. Now, Unix and Mac and Linux are both Unix architectures. Windows is its own shebang, and so it's understandable that there's different ways of compiling stuff for the different software architectures. So that's all right. After you get that, you should be able to do the making, though. It's definitely something you're going to encounter more than once in this class and constantly when you're doing bioinformatics. Okay, so some new software comes out. Usually it goes up on GitHub or in like BioPython, the Anaconda system, or somewhere online, and it's not going to work perfectly right out of the box. You have to figure out how to get it installed. The benefit of being able to get stuff installed and find missing libraries and do this kind of pseudo bioinformatics that we're doing is that you get to be the one using the cutting edge tools, pasting them together, right? You don't have to wait 5-6 years for it to become a point and click system. All right. While Windows folks are getting that downloaded and following the 8 steps, the 8 annoying steps to get Make working, let's take a look at this actual program that we're going to be using. Share my screen again. All right, so assignment 4 has us using this and figuring it out. Essentially, your assignment is to figure out how to use seqtk, but I'll give you a few hints here. So here's some examples. You can convert FASTQ to FASTA with it. Well, that's nice. We know how to do that with sed already just by copying and pasting that, but that's kind of a lot to remember. So we could just do seqtk, seek our FASTA file, or our in file, and then send it to our out. All right, convert Illumina 1.3 plus FASTQ to FASTA and mass bases with quality lower than 20 to lower cases. That's crazy. All right. So we're saying AQ64. What in the world is that? So we can take the old version of the Fred scores, convert them into the new version so they play well with our other sequences. Okay. Mask things that have a quality of 20 or less. That's real nice. We could fold long fast A or fast Q lines and remove comments. Convert multi-line FASTQ to 4-line FASTQ. What? Yep, there are versions of FASTQ out there that aren't every 4 lines. Some of them have gap lines between stuff. That's pretty annoying. Reverse complement. Okay. Your assignment is going to have you doing some stuff like trimming the first 50 nucleotides from each sequence. Okay. How do I learn about this seq-tk program?
Read me on GitHub.
Well, it's not telling me everything.
Stack Overflow.
Stack Overflow maybe, but how do I do it for reals?
I can see a manual entry.
Yeah, so I just typed in seq-tk. That works on my computer because it's in my path. Once you get yours in your path, that'll work. And it tells me my version. And then it says usage, command, and arguments. And here's the commands I can do. I can do seq, so those are common transformations of FASTA and FASTQ. I can subsample sequences if I wanted to pull random stuff out. Okay. I could extract subsequences, so just positions 50 through 100. I can trim them based on quality scores. I can find regional heterozygosity, GC regions, point mutate FASTA at specified positions. So this is getting pretty powerful right here. Let's take a look at seq, that command. So I'll say seq-tk seq. And then it's going to give me my options. Mass basis of quality lower than or higher than. And so I'm just starting to add little flags. Okay. So how about R, reverse complement? So the command starts to build on itself. We're using the seq-tk program. Within it, we're using the seq command, and then we're giving it some flags here. Reverse complement. Oh, where am I? There I am. Seq-tk, seq, reverse complement, assignment 1, file 1.fasta, head 2. Oops. All right. Head to assignment 4 file 1.fasta. So that gives me my first name sequence and the sequence itself. And then I'm going to try the reverse complement. Did it work? Yes or no?
Yep.
So we start out with CTT in our original. The reverse complement is GAA. Yep. Okay, so we can get reverse complement of all of our reads at once. How would I then maybe just take the first 10 nucleotide positions from this? Any guesses? I'll tell you right now, I don't know.
Does
But
head only do like the first 10 lines?
Yeah. I'm thinking with this seek TK program, now that we've
What
got-
about? Oh, sorry.
Yeah.
Cut capital N in SeekDK.
cut capital N?
Yeah, SeekDK space cut capital N.
There's no cut command in seek TK.
There's a 9, huh?
You have a
Okay.
cut?
Lower. Cut N, cut sequences that I can see it on your screen.
Where?
Oh, go back to like a base SeekDK. Second from the
right here?
yeah.
Okay, let's look at that. That's doing something different.
Okay.
So that's looking for basically like a poly A tail or some repeat sequence to the Tata box, whatever, and being able to cut that off at the end.
I thought that N was just like a variable place, like replacement.
No. So maybe it's here in seek. So seek TK. We'll try that seek command again. We'll look for something. Mask regions, drop sequences. So maybe it's not here in the seek. I don't see a way to just return the first 10 nucleotides.
Is there like an inverse function, kind of like when you're doing wget and you do -v? Is there that kind of thing where you can cut, instead of cutting them out, you can do the inverse of cut and cut everything else out?
There might be, but I don't see that either. Let's see, trim FASTQ using the Fred algorithm. Choose a random base, extract the position. Maybe it's subseq. Extract subsequences. Maybe that'll work. Seek TK subseq.
I think it takes a random sample.
Yeah. That's no good. All right, Google. Seek TK. Cut first and nucleotides. It's just taking us right to the GitHub page. Man, I love this. Trim. There we go. Seek TK. Do we have a trim? Trim FQ. Okay, so we can trim based on quality scores, so we can get rid of all the bases at the beginning or end that are low quality. Or we could just go ahead and trim some integer from the left or the right. Maximally trim down to this many base pairs. So I'm going to try L 10. And that didn't work. How about a capital L? There we go. All right. So as we wrap up today, I know we spent a lot of time downloading stuff, but that's actually normal. It'll get easier as we move on. This SeqTK program is going to come in super handy for us over and over and over again. You'll notice that I don't know how to use everything in it because often I haven't had to, but there's functionality there. This whole ridiculous exercise of me flailing around trying to figure out SeqTK hopefully was useful to you. Trying to show you kind of the metacognitive stuff that goes on in the background of trying to answer a question. So this should help you with your assignment. We're exploring the SeqTK program, seeing what it can do, and trying stuff to see if it actually gives us what we want. Okay. So your assignment is that kind of stuff, right? So make a FastSave version of the reverse complement of your new trimmed file. All right, so it's just kind of walking you through some things. These are all things that I did try out, and they did work as long as you get SeqTK working. Okay. Reminder about sed. It takes standard in and gives standard out. And what it really is looking for is some expression. So let's see here. We'll run that again. We'll type that to sed. We can search for TT and change it to dash 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 globally. So we can edit all of our sequences at once using SeqTK and sed together. Starting to see how this is just duct taped garbage kind of congealed together into this pipeline that eventually gets what hopefully you're looking for. Maybe? I don't know. We're still in the nether zone of the learning curve here. It's kind of rough. Any questions? Concerns? Hopes and dreams? Fears?
Probably too many fears to get into right now.
Well, we can start. We got a minute or two. It's the #1 fear.
Contaminating everything in the lab.
Oh, you don't have to worry about that here. This is bioinformatics.
Yeah, but that's my
All right.
#1 fear constantly.
Okay. Well,
Here's another concern. I tried to download the SeqTK the way you said it, and when I tried to use it, it didn't work, and it just recommended that I use like sudo apt-get SeqTK, and that worked.
yeah.
I'm just wondering why. Like, even though I put it in a.
The reason I didn't show you the sudo apt-get install SeqTK is because that only works for Linux users, and I think there's 3 of us. Yeah. And the other way should work as well. Eventually, you just have to move it to your path.
All right, sounds good.
All right. Anyone else? Please, please, please read those essays. Start using the website. You know, I put that together on purpose for you. We've got the FastX toolkit you can also download. Instructions are there in week 4. So for your practice, look at the practice questions and see if you can get the FastX toolkit installed. You will also need to install a library to get it working. These are the kind of skills that employers want you to be able to like use new software and get it working correctly. It's also the skills that you want because you don't want to be 10 years behind the curve trying to use old algorithms or anything. So get your practice on that. You need to have read through chapter 10 before Wednesday also. All right. I'll see you. Wait, Wednesday. I mean Thursday. Whatever. It's been a long week already. All right. See you Thursday.